person 5 feet tall is walking toward an 18-foot pole. The light is positioned at the top of the pole. Find the rate at which the length of the person's shadow is changing when the person is 30 feet from the pole and walking at a constant speed of 6 feet per second.
Okay, so we have a light pole. So let's go ahead and make our pole with the light. That's my artistic ability. Impressive, right? And then the pole is going to cast a shadow that's going to create a right angle, or right triangle, I mean. Is the person at the tip or walking towards it? Okay, so anywhere in the middle, somewhere, let's draw a person. And that person is also at a right angle. So when you guys think about a right triangle, the first thing, what happened to their arm? The first thing that goes to your mind is use Pythagorean, right? If you have a triangle within a triangle, meaning a similar triangle, we're looking at proportion. Just keep that in mind, okay? So let's see what information I know. The light pole is how tall? 18 feet. And I'm going to go ahead and say we have something over here and something over here that's going to change as a person is moving. So I'm going to call that F. I'm going to call this L. As a whole, let's call it T. Do we know how tall the person is? 5 feet. So I should have drawn this person way further back, but that's okay. Let's all write out Fuiki. What are we looking for? The changing of the person's shadow. So let's go ahead and make our shadow right here. And the shadow part is the L. So we're looking for DL over DT. Is there a constant value given when something is how many feet? 30 feet. So we have the person is 30 feet from the pole. So the person is walking towards, so you draw the arrow. So I would say the F is 30. From the person to the pole. What given rate do I have? What given rate?
60.
The walking at a constant speed of 6 feet per second. So we're looking at the person that is actually going towards, since we're going towards, that's going to be the F value. DF over DT. So as we walk closer and closer and closer to, is it getting bigger or smaller? It's getting smaller. So can we anticipate that's going to be a negative value? It's getting smaller. All right, so again, we're not looking at Pythagorean. When you have a triangle within a triangle, we're looking at proportion. So I would do 18 over T over 5 over what? The smaller triangle has what as a base?
L.
L, very good. Let's see if I'm happy with all the variables. We're looking for the L, so I'm happy with this one. We want something in terms of the F, so I am not happy with the T. So we have to go ahead and modify that. So let's rewrite on the top. 18 over. Instead of our T, can I put the F and the L together? So we have F plus L is equal to 5 over L. And again, just like on the notes, let's cross multiply. We have 18L is equal to, when I cross multiply right here, 5 is distribution. 5F plus 5L. I have L's in 2 different locations. Let's go ahead and simplify that. How would I simplify that? 13L by subtracting 5L on both sides. 5F. Now let's derive the function with respect to T. So we get 13 dl over dt is equal to 5 df over dt. And let's see what I have. We're looking for dl. We know df. Let's plug it in. So we have 13 dl over dt is equal to 5 times negative 6. And really in the end, that's going to give us, I'm going to write it over here, dl over dt, negative 30 over 13. That will be feet per second.